Hi, my name is Carl Dobner. I'm the Head of Network Operations for Stream Networks. Today I'm just going to do a very quick demonstration on how AI routing can work across our SD-WAN platform. What I've done is built a SLA policy for the application Microsoft Teams. So when I apply some jitter to the primary circuit, that application will fail over to an alternative route. Like I say, the SLA policy I've built is purely for Microsoft Teams, so no other applications will be failed over. So things like HTTP, web browsing, YouTube, pings, they'll probably be affected, or they will be affected by the latency, so they'll just time out and become unresponsive. You can see here I've got the primary circuit. This is my backup circuit here. This is the CSO platform. This will also become unresponsive just because it's an HTTP website. So yeah, before I do that, let me just make a quick call to my colleague Matt, and then once we've got a call active, what I'll do is I apply the jitter to the primary circuit. Hi Matt, I'm just doing my demo on AppQOE. So I built a policy for Microsoft Teams. So once I apply some latency to the primary circuit, hopefully our call will stay up, but things like YouTube and my ping will stop responding.
Okay, yeah, so it's demonstrating the sort of the power of the AI behind the technology and how it can seamlessly fail over UC and Teams traffic.
Yeah.
Yeah.
Okay, so I'm just going to apply some latency to the primary circuit now. Okay, I've just applied that. Let's have a look. So my pings are timing out. Okay, and if I go to a couple of websites quickly and click around a few different links, so that random article, yeah, they've stopped responding there. Click on a picture of Saka on a unicorn, that's not loading. YouTube, bit of Harry Kane highlights.
It's coming home, Carl, it's coming home.
Yeah. So that's it, yeah, my browsing has stopped working, YouTube stopped streaming, and ping is timing out, but that's because they're not in the SLA policy, but Microsoft Teams is, and obviously that call's still successful.
Good.
So I think that's a successful test.
Yeah, it just shows the power of the technology, because as well as Teams, you know, any application traffic, things like Office 365, remote desktop, Amazon, Azure traffic can identify actual applications over and above protocols. So you can actually you know, apply SLAs to individual applications to fail over, and it all does it automatically via the AppQOE engine. It brings AI to the network, doesn't it? Good stuff.
Yeah, it's very handy for critical apps like RDP and VoIP.
Yeah.
So that's good.
Is that the end of me being used as a guinea pig?
Yeah, I can just remove the latency just to see. Should seamlessly fail back as well. There we go, so I've removed the latency now, my pings are back instantly. Websites are loading again. Let's have a look. And YouTube videos. Yeah, everything's working there. That's great, thanks Matt.
Good, okay, over and out.
Cheers, bye. Okay, and if I go back to the CSO platform here, so look at the two circuits, bring this time frame down a little bit. Okay, and as you can see there, we've got most of the traffic was still on the primary circuit, although it wasn't actually getting there, or the latency was very high. There was still traffic on that circuit, but this traffic here was the Microsoft Teams call. We can check that as well by changing this profile here to Microsoft Teams, and it highlights it there.
I'll get there. It's just a learning curve.
Okay, and I think that completes the end of that demo. Thanks for watching.